Good day everyone. So in this video, we will discuss about the two frustum, a frustum of a regular pyramid and a frustum of a right circular cone. But first, let us define what is frustum. In geometry, a frustum is the portion of a solid that lies between one or two parallel planes cutting it. Now, a frustum of a regular pyramid is the portion of a regular pyramid included between the base and the section parallel to the base.
So hello everyone, my name is FNA Torino and I am here to discuss to you the first property of a frustum of a regular pyramid. Slant height of the frustum of a regular pyramid is the altitude of the face. And take a look at this picture. So as you can see in the picture, that is a regular pyramid or a three-dimensional pyramid. So if you're going to determine where is the frustum of a regular pyramid, we're going to cut, or a plane object will going to cut the apex of the regular pyramid. Take a look. And that area will be cut by a plane figure. After a regular pyramid were cut by a plane figure, then this will be the result. Always remember that altitude is the distance from the apex to the base of the pyramid. If this is the apex and this is the base of a parallel, then from here to here is the altitude of the regular pyramid. But stated in the first property of the frustum of a regular pyramid that the slant height of a frustum of a regular pyramid is the altitude of the face. So if this is the slant height of the regular pyramid, then from here to here, then it states that the altitude of the face of the frustum is here. So this is the slant height of the frustum of a regular pyramid, or the altitude of the face.
The lateral edges of a frustum of a regular pyramid are equal, and the faces are equal isosceles trapezoids. The bases of a frustum of a regular pyramid are similar regular polygons. If these polygons become equal, the frustum will become prism.
The lateral faces of a frustum of a regular pyramid are congruent isosceles trapezoid. An isosceles trapezoid is a trapezoid where the non-parallel sides are congruent. The bases of a frustum of a regular pyramid are similar to regular polygon. I am Julyda BSED, and today's video I will show you how to find the lateral area of frustum of a regular pyramid. Lateral area of frustum of a regular pyramid is 1/2 the sum of the perimeter of the bases multiplied by the slant height. We can use the formula LA is equals to perimeter 1 plus perimeter 2 over 2 multiplied by the L, or the slant height, where the P1 is the perimeter of the lower base, then the P2 is the perimeter of the upper base, and the L is the slant height. For example, if the lower base of frustum of a regular pyramid is equals to 30 cm, then the upper base is equals to 10 cm, then the slant height is 6. Find the lateral area. First, we need to use the formula LA is equals to perimeter 1 plus perimeter 2 over 2 multiplied by the slant height, or the L. We need to substitute, which is LA is equals to P1 will be 30 cm plus P2 will be 10 cm over 2, then multiplied by 6. 30 plus 10 is equals to 40, then copy the 2 and 6, which is 40 divided by 2 multiplied by 6. 40 divided by 2 is equals to 20, then 20 multiplied by 6 is equals to 120 centimeter. The lateral area of frustum of a regular pyramid is 120 centimeter.
A pleasant day to everyone. I'm Jella Crystal Bertidaso and I'm going to discuss the total surface area of frustum of a regular pyramid. The total surface area of a frustum of a regular pyramid is the sum of the area of the bases and the lateral area. The formula of the surface area of a frustum of a regular pyramid is surface area is equals to base 1 plus base 2 plus lateral area. For example, if the lower base of a frustum of a regular pyramid is 18 cm and the upper base is 20 and the slant height is 10, find the total surface area. First is we need to find the lateral area before we can solve the total surface area. The formula of lateral area is LA is equals to perimeter 1 plus perimeter 2 is over 2 multiplied by the L or the slant height. We need to substitute, which is LA is equals to P1 will be 18 plus P2 will be 20 over 2 and multiplied by the 10. Then the lateral area is equals to 190 centimeters squared. So we have a lateral area which is 190 centimeters. So we can solve now the total surface area. The formula of the total surface area of a frustum of regular pyramid is SA is equals to base 1 plus base 2 plus lateral area. We need to substitute, which is base 1 will be 18 plus base 2 will be 20 plus the lateral area which is 190 centimeter. So the total surface area is equals to 228 centimeters squared.
Hi, I am Ronnie B. Serrada. I am here to discuss the volume of frustum of a regular pyramid. The volume of frustum of a regular pyramid is equal to 1/3 the production of latitude in the sum of the area of the bases and the mean proportional area between the bases. Example, the flower base, 12-inch high, is in the form of a frustum of a square pyramid. Those bases edges are 8 inches and 4 inches. Find the volume of the flower bases. Using the formula, we can solve the volume of the bases. Solution.
Lateral area of a granite block.
Lateral area of a granite block. A block of a granite is in the form of the frustum of a square pyramid whose upper and lower sides are 4 inches and 7 inches respectively. If each of the lateral faces is inclined at an angle of 60 degrees, find its solution.
To find the lateral area, we need the perimeter of the bases and the slant height.
P1 is equals to 4 times 7 equals 28 inches. P2, 4 times 4 is equals to 16 inches. The slant height can be solved using right triangle ACB. Cosine theta is equals to BC over AB. Cosine 60 degree is equals to 1.5 over AB. AB is equals to 1.5 over cosine 60 degrees equals 3 inches.
Formula, lateral area LA equals P1 perimeter of the lower base plus P2 perimeter of the upper base times L slant height over or divided by 2.
Solving for lateral area, we have LA equals P1 plus P2 over 2 times L, and it's equal to 28 plus 16 over 2 times 3. So the answer is 66 inches squared.
Therefore, the lateral area is 66 squared inches.
A pleasant day for everyone. I am Lauren C. Tablason and I'm going to discuss briefly the frustum of right circular cone. As you can see above, what can you observe about the right circular cone? One plane parallel to its base cuts off this right circular cone, and if nakat na siya, you can obtain a smaller cone, and the portion of tail in the base is, ito na yung tinatawag na frustum of right circular cone. Ito yan, oh. There are many objects na kasing shape ng frustum of right circular cone, and those are the cups, glasses, buckets, and many more. I'm going to show a picture above. The properties of frustum of a right circular cone. First is slant height of frustum of a right circular cone is same all throughout. As you can see in the picture that the slant height is denoted by L and it is equal all throughout. And the second property is the altitude of frustum right circular cone is equal to the length of perpendicular line between two bases. As you can observe in the picture given that the altitude or the height is perpendicular distance between two bases, and it is denoted by H.
Good day everyone, I am Elson Sanchez and I will discuss to you of how to solve the lateral area of the frustum of a right circular cone. The lateral area of a frustum of a right circular cone is 1/2 the sum of the circumference of the bases multiplied by the slant height.
The following are the formulas in computing for the lateral area. Here's the formula. LA equals open parenthesis C1 plus C2 over 2 close parenthesis small letter L, where C1 is the circumference of the lower base, C2 is the circumference of the upper base, and while the small letter L is the slant height.
The surface area or total surface area SA of frustum of a right circular cone is the sum of the bases and the lateral area.
The formula of surface area is B1 plus B2 plus lateral area, where the B1 is the area of the lower base and the B2 is the area of the upper base.
The volume of frustums of any cone is equal to 1/3 the product of altitude and the sum of the areas of the bases and the mean proportional area between the bases. The formula is V equals to 1/3 B1 plus B2 plus the square root of B1 and B2 times H, where H is the height, B1 is the area of the lower base, B2 is the area of the upper base, and square root of B1 and B2 is the mean proportional area between the bases.
Here are the examples on how to solve the lateral area, surface area, and volume of frustum of a right circular cone. Example number 1. Given a frustum of a right circular cone as a height of 14 centimeters and 6 centimeters respectively, find the following: the lateral area, total surface area, and the last one is the volume. Solution for lateral area. To find the lateral area, we need the circumferences of the bases and the slant height. Note that the radius of the upper base is 3 cm and the radius of the lower base is 6 cm. To solve for the slant height, we consider the half of the vertical section of the frustum. To solve for the lateral area, you are going to find first the C1 and the C2. C1 equals 2 pi r equals 2 pi times 6 equals 12 pi centimeter. C2 equals 2 pi r equals 2 pi times 6 equals 12 pi centimeter. The slant height can be solved using right angle BEC. Small letter L, square root of line BE squared plus line EC squared equals square root of 14 squared plus 3 squared equals square root of 205, approximately 14.32 centimeter. Solving for lateral area, we have the LA equals open parenthesis C1 plus C2 over 2 close parenthesis small letter L equals open parenthesis 12 pi plus 6 pi over 2 close parenthesis times 14.32, and the answer is 404.89 centimeters square. Therefore, the lateral area is 404.89 square centimeter.
To find the surface area, we need to find the area of the lower and the upper base of the frontum. The formula of lower base and the upper base is pi times r squared, where the r is the radius of the base. To solve, the lower base is pi times 6 cm squared is equal to 36 pi cm squared, while the upper base is pi times 3 cm squared is equal to 9 pi cm squared. After we solve the lower and upper base, we are now solving for the surface area using the formula of surface area B1 plus B2 plus lateral area. The B1 is 36 pi plus B2 9 pi plus the lateral area, which is 400.89, is approximately equal to 546.26 centimeters squared.
Solving for the volume, we have V equals to 1/3 B1 plus B2 plus square root of B1 B2 times H. V equals to 1/3 36 pi plus 9 pi plus square root of 36 pi times 9 pi times 14 equals to 294 pi is equal to 923.63 centimeter cube. Therefore, the volume is 923.63 cubic centimeter.